now. Okay, and we'll minimize this. We are recording, so let's go back to the screen share and back to document and Google Chrome. Here we are. Oh, and here's D coming in. So let me get D here. Okay, I know you're in here somewhere hiding. There you are. D, can you hear me yet?
Yes, I can hear you.
Okay. Had you sent me a text because I was doing something and it popped up? I thought it was from you, and then later I couldn't find it anywhere. So I don't know if, yeah, and was it something to do with the test? Okay, I'm about to open the test now, so I wanted to do that while we're there. So if you're looking at the screen now, hopefully everybody can see we're in Blackboard for this course, so I'm going to shut off this screen here, and I'm trying to remember. I think I'm going to have to move Anaya again. Okay. Going to close this off. Trying to remember which week I gave it to you. Test 1. I don't think I could show up here, so I'm going to try to see if it does. I don't believe it does. For some reason that's not open. There it goes. Okay. No, I could not put it here because they didn't allow me a place to do it. I tried and I couldn't get it in there. So I'm going to close that down again. Now I'm going to have to move. Shamari is in the way again. So I'm going to, well, moved her too soon. Close that off and go back to the top. This is such a fun thing to navigate, don't you think? I do not like that. Okay, under messages, okay, Janae, right, go to messages. You see where I'm clicking? The little envelope. And here you see, hopefully when I move y'all out of the way, here is the first test. I'm going to click on this and then y'all are going to be in the way again. So let me move y'all out of the way again. And now you're in the way again. Okay. On this one, this is the Word file. And some people had said they couldn't open everything in the Word file. Here's graph paper in a PDF file. So I sent it again. So I'm going to close this out if I can. And here is the test again here under messages. Here's the PDF file. Okay. Now it says Q1, but that's test 1. So if you could open the Word document, use the first message I sent. If you can't open that Word document, use the second message. But the first message does have the graph paper. It's pretty lousy graph paper because it was light blue graph paper, and my Adobe scan just did not pick it up very well. So does that get you there? Janae, were you able to follow that?
Yes, sir. I'm looking at it. I'm going to have to pull it up on my laptop, but I'm on my phone.
Okay, right. Okay, but you know where to go to get it. So it depends on whether you can open the Word file or the PDF, whichever you want to open and work on. Right. Now, I'm going to now answer Dee's question for everybody. I'm going to try to find the right file here. And okay, I'm going to pull it up. It's the same one, but it's quiz 1. I'm going to pull it up in WordPerfect. Y'all can't see this. I've got it in 3 ways: WordPerfect, Adobe, and Word. But I'm going to do the WordPerfect because I know that one is what I typed in originally. So it should be there. And now I'm going to pull back to the screen share, and there it is. Okay, it was number 3. That's the one you had the question about? Okay, now remember, this is a piecewise defined function. G is defined as 2w for any time w is less than -1. It's this definition anytime w is between -1 and 1, and it's this definition anytime w is greater than 1. Well, the w is the thing that goes in the parentheses, the independent variable. Here it asks for g of 1/4. Now the first thing you do is find out where you are, Waldo. Are you up here? Are you in here? Are you down there? Where is 1/4? Is it less than -1, between -1 and 1, or greater than 1? Once you decide that, that's the one that you use. One and only one. The one that whoops. Ivan's in the waiting room. Let me get him in here. Sorry about stopping in the middle of things. I didn't see him waiting. So I think that's him right here. Yeah. I'm all the way across the page and it's hard to stay online. Okay. Did that answer your question, D? It did. Okay. Any others while we got the quiz open here, or the test open here? All right. And as I said before, try to get this in this week, because I have a feeling that if not, I don't think it'll be today. I imagine on Thursday we'll be finishing 1.9 and I'll be publishing the next test, which is a 2-pager. It's going to cover 1 through 1.4 to 1.6 like this one did, but it's also going to cover 1.7 through 1.9. So it's going to cover everything we do in chapter 1. So the first page will be it'll be sort of like this, but not the same questions. The second page, and maybe some of the first page, will be stuff from the last 3 sections. So it's going to be a little heavier toward the last 3 sections, a little lighter toward this, because I've already tested you on it once. So try to get this first test in this week if you can. All right, any other questions while we have the test up? Okay, so let's go back to the PowerPoint, and that's 1.8, and it used to be here. It was here before, and now I don't see it at all. Gag, this aggravates me. Okay, so going back here, open the PowerPoint, okay, and then go back and try another screen share. So I think I have to cancel this screen share first. Okay, let's do a new share here. There's 1.8 now, and we've lost 1.9, but we'll worry about that later. Okay, we'll begin the slideshow from current slide, because this is where we left off last time. We finished example 5, and this is the very end of example 5. And is somebody else trying to come in? Let me see. Yes, Diana is here. So let me admit her. All right, Diana's here. All right. Let's see, we should have 17 students here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. Got it. Okay. Now, I've had a couple of good questions already, and if you did get here a little later, what you can do is listen to the YouTube video, because I've been recording it. One was where to find the test, and we did that, and I answered a question about question 3 on the test. So those are all there. Any other questions before we get started today? All right. Now where we are, yes. I don't do quote midterms. I mean, how I think of it is you start the term and you end the term, and any test in the middle of the term is a midterm. So this first test was a midterm, the next one will be a midterm, the one after that will be a midterm, it'll be in the middle of the terms, and then the final will be at the end of the term. So I don't do a midterm per se. It's all these chapter tests. Otherwise, we'd just be sitting around testing all the time, and that would just get, you know, it gives me more work, you more work, and prevents moving along faster. Is that a decent answer to your question? Okay, good. Surely. All right. Now, we finished example 5 last time. Example 6 is not on the PowerPoints. So, and I think maybe 7 is, but 6 is not. So let me get my whiteboard here. I mean, we're going to go to the whiteboard, and we're going to do example 6. Let me just, well, this thing is sort of aggravating. Okay, this is the end of 5. Okay, so let's go to the whiteboard. Okay, I've got to do some moving around here too. Y'all can't see it, but there's a toolbar that sits right in the whiteboard, so it blocks what I can write. And then the whiteboard is over behind y'all sort of, so I move it to the left and up as far as I can so I get maximum white space. So here's example 6. Now what we were talking about before was a composite function, and here's the functions we're living with. F of x is equal to x squared minus 9, and g of x is equal to the square root. Oops, here comes Terrell. Okay, let me get him marked before we go any further. I've got too many things scattered too far apart here. Terrell is here. Okay, and Ivan, I think I had him before. He must have got bumped out and coming back again. So I should be up to 18 students here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. Yeah, I got it. So I think I got everybody. And for those who just came in, are still coming in, we did have a couple of good questions earlier. One was about the test, where to find it, and we went through that. So if you need help with that, be sure to check your YouTube videos once they load. And let's do a timeout now. Okay, my schedule has changed because the first mini term is over with. Okay, that ended last week. Second mini term starts this week. Here's the big change for me. First mini term I had say again? Okay, first mini term I had a physical science class that went from 1:15 on Tuesday, Thursday afternoon until 5:45 in the evening. So basically my whole afternoon was tied up with that class. Well, that one's over with, and now I pick up, Diana was in it, okay? Now I pick up the second mini term class. However, because the automotive students, some of them need to take it, they don't get through their classes until 3, so I had to start this one at 3:15, and it goes until 7:45. Okay, so what that means for you guys, a couple of things. Number one, my office hours have changed. Before I didn't have any office hours in the middle of the day, now I do. From 12:45 until 3:15, I have office hours. Now, when I put it on the I've got to, change things on Blackboard, I'll probably just put 1 to 3, okay, because I'll have a little bit of time in, at the end of one class before the other one begins, okay, but 1 to 3 will be my office hours there, okay. That's on Tuesday and Thursday. They weren't there before, so now added some new office hours. But the other thing, and this is maybe the thing that'll hit you the hardest, is I won't be able necessarily to load the Blackboard, the YouTube videos into the playlist until after that last class, and that last class goes until 7:45. So basically it's going to be 8 o'clock or later before I probably get those in there. Now, it has been pretty late sometimes before I get them in there anyway, but just beware, I won't be able to get them in much earlier because I'm going to be in class from 3:15 until 7:45. And Diana, are you in the second class too? Okay, I was thinking you probably were too, so we'll be there late tonight, okay, and every Tuesday and Thursday from now on. Okay, so let's get back to math. And what I was saying for you folks who just came in, once you get to see the YouTube videos, you'll get to see the question they had about question 3, and also how to find it on the test on Blackboard, where to go to find it. And then the other thing I was telling was also try to wrap up that first test this week, because either Thursday or Tuesday of next week I'll be giving you the next test. Okay, so g of x, this is example 6 on page 79. Chapter 1, functions of the graph. 1.8 is combinations of functions and composite functions. We're doing composite functions now, and here are the functions we're dealing with. F of x is x squared plus minus 9, and g of x is the square root of 9 minus x squared. Okay. Now, all it's asking for is the domain of the function. But what they take you through, and I think it's a good idea, is to take you through how to do that. But before we get started, that domain of a function is pretty important here, because they're asking for the domain of f composed with g. So that means the input, the domain, is what goes into g. Okay, so that's what we need to determine here. We're not really interested too much in what goes into f. Anything could go into f. It's a polynomial function. G is the one that concerns us. Now, when you look at that, you know that whatever's under the radical, 9 minus x squared is under the radical. You know that has to be non-negative, because you can't take the square root of a negative number. So this has to be greater than or equal to, if I could get that to go away. I don't know if you can see it, but it's a pain in the neck for me. It pops up there and blocks my writing. Greater than or equal to 0. Okay? Now, again, just like we did before, this can be factored into 3 plus x times 3 minus x. Now, you don't have to do all this, but this is the way to be certain about it. If you're looking at this and saying, hey, what values can x take on? Let's just think about it a minute. And this sort of gives us a hint. Okay, 3 may be a limit here, because if you had 3 in here, 9 minus 3 squared would be 9. 9 minus 9 is 0. So you're right at the border there. Okay, negative 3 would also be an issue, because 9 minus negative 3 squared is still 9. So that's going to be 0. So let's see. The negative 3 and positive 3 are your endpoints. Let's see, do we need to be outside them or inside them? Well, let's pick a number inside negative 3 to 3. Well, why not 0? Okay, 0 certainly works. Let's pick something outside -3 to 3, like maybe 4. You put a 4 in here, you get 9 minus 16. No way. You put a -4 in there, 9 minus 16, no way. So it looks like to me that your domain of G, the domain of G, has then got to be, and you can write it several ways. I'll put it in interval notation because that's what the book usually does, from -3 to 3. Okay? Now, I know, from what I know, that's also going to be the domain of your answer. But let's go on and do what they want us to do here. Okay? F composed with G, does anyone remember what that means? That means, think of the little circle there, which means composition. Think of that as an O, meaning of. That means F of G of X. And that means you put the G of X inside, so it's going to be F of the square root of 9 minus X squared. Knowing that you can only put X values between -3 and 3 in there because that's the only thing that's defined. Well, what does F do for you? F says take what's inside the parentheses, square it, and subtract 9 from it. Okay, so let's do that. That would be what's inside the parentheses, which is the square root of 9 minus X squared, square that, and then subtract 9 from it. Okay, so what does that give you? When you square a square root, that undoes both of them. Okay, so that gives you 9 minus X squared minus 9, which gives you, these add to 0, negative X squared. Now if you waited till this point and say, okay, what's the domain of that? You'd say all real numbers. No, it's not, because the G had a limit on it. You have to respect that limit here. So the domain here is on the interval -3 to 3. Because you couldn't have gotten to this point if you put any other number in here or anywhere there. So that is the domain of the function. Okay? Even though it looks like it would be good beyond that, can't do it. Cannot do it. Okay? Now, here's a graph of that function. Thank goodness they put it in the book so I can hold it up and show it to you. There's the graph of that. And you see minus X squared would go on forever, but here you have to limit it from -3, I think there's -3 there, to +3 here. That's as far as it can go. It does have those endpoints on it, but it can't go beyond that because you could not do G beyond that. So does that make sense? Your input, your domain, is what goes into the innermost function. That makes sense in the outermost function. Well, the outermost function, anything would make sense. The innermost function, though, that's the one you have to pay attention to. And that, oh, here comes, oh, Diana must have left when I asked her the question, and she came back. Good. All right. Any questions on example 6? All right. Following example 6, as in all the examples, there is a checkpoint. Okay? And please do the checkpoints as soon as you can after class, because that reinforces the type of stuff we just did in class. So let's go back to our, if I can get the cursor to show up here, back to the PowerPoints. Okay, let me make sure nobody else is out there. Okay, they're not, that I can see. So let's go back to the PowerPoints, and we're in 1.8. All right, we'll go resume the slideshow, and we'll go from here. In your book it says in examples 5 and 6, but because the slideshow didn't show but 5 and didn't show 6, then in example 5 and 6 you form the composition of two given functions. In calculus, it's also important to be able to identify two functions that make up a given function. For instance, if this was your original function, h of x is equal to 3x minus 5 cubed, that is the composition of your outermost function, f, which is the cubing function, x cubed, and the innermost function, what's inside here, 3x minus 5. That is, h of x is equal to 3x minus 5 cubed, which is g of x, 3x minus 5, cubed, which is f of g of x. So what you've just done is what they call decomposing a function, and that's what it's going to talk about next. Basically, to decompose a composite function, look for an inner function and the outer function. In that function h, the 3x minus 5 was the innermost function by itself in there, and the outer function was the cubing function, which you can express as just x cubed. Okay? Now, there are some others that you actually use. You can do 2 or 3 or 4 compositions. Okay? So you might have to decompose a couple of times or more. Okay? Now, they're skipping example 7. Okay? So let's us do example 7 because they're moving to the application. So let me get my pad back, my pen back, everything back, and go back to the whiteboard. Okay? Anyone need that left up a little bit longer? I hear nothing, so I'll clear it. Now, here's a function, and they named it h of x again. H of x is equal to 1 over x minus 2 squared. Okay? And it says write that as a composition of two functions. Now I can think of at least 2 different ways to write this as a composition of two functions, and I can think of one way to write it as a composition of 3 functions. Okay? Now, what the book chooses, which I think I would probably choose too, is let's let the innermost function, the g of x, be the x minus 2. Okay? So I'll say let g of x be the innermost function here, x minus 2. Okay? Then, what do we have left? The outer function would be your f of x, and it doesn't have to be, oh, here comes Brianna. We have Briantra here, but now we have Brianna here. So it's going to take me a minute to get over here and find her and mark her. She has been marked. Okay. All right. Then your f of x, and by the way, Brianna, we're in chapter 1, functions of the graphs, section 1.8, combinations of functions, also composite functions. We're on the composite functions part now. We're on page 79, bottom of the page, example 7. Not on the PowerPoint, so we're working here. So your f function, what we're doing is decomposing a function. Here was your function h of x, 1 over x minus 2 squared. So we decided to let the innermost function g of x be x minus 2, and that would make your outer function f of x equal to 1 over x squared. Okay. That's one way to do it, and that's what the book did. Okay. Now, here's another way you could have done it. You could have let g of x equal x minus 2 squared, and then let the f of x, the outer function, just be the reciprocal function, 1 over x. That would work equally well. Okay? And I guess there's another way. Whoa, here's Brianna. Must not have gotten in well last time, so I'm going to admit her again. Okay. I guess we could have done it another way. Let's do it this way. Let g of x be 1 over let me see if that would work. Nah, I don't think so. Let's not do that. That would be a little too confusing. Okay, as if this isn't confusing enough. Okay, now the other way I said we could do a three-way composite function with h of x being that, and we need the name of another function. We've used f, g, h. Usually we don't use I, j, or k. Let's use m. Okay, let's let m of x be, like we did before, the innermost function x minus 2. Then, and for some reason the pen's not writing well, I'm writing too fast probably, then g of x would then be the squaring function, x squared. And then the f of x could be the reciprocal function. So we got f of g of x, of m, okay? A three-way composite function. You can do as many as you need. And there's a lot of times there is only one reasonably right answer. This one had several potentially correct answers. Okay? If you got it right, you're going to get credit for it. The book did it this way, and by the way, they do have a checkpoint after that. Now, do you think we have time for a dumb story? And by the way, this is called decomposing a function. Composing a function when you put them together. Decomposing is when you take them apart. Right? Do you have time for a dumb story? I know we're a little behind. You want a dumb story or not? Okay. Well, this concerns a famous musician. You probably heard of him, Ludwig van Beethoven. Now, that's not the big shaggy dog, the great Saint Bernard dog. That's a Hollywood thing. But this is Beethoven. Beethoven wrote some of the grandest music ever written. Okay. Beethoven's Fifth Symphony is probably one of the premier pieces of music ever put to paper. Okay, da 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 da. You hear it all the time, and it's just a wonderful, powerful piece of music. But from everything I've gathered, Beethoven was sort of a rascable old coot. I don't know that he ever married. Maybe he did, maybe he didn't. But just like music today, can anyone say who won the Grammy back in 5 years ago? Some of you may be really big music fans and you might remember that, but the odds are, no, you can't remember it. I can't. I know I can't. And music changes. In my lifetime, I don't know how many different genres of music have been popular and then faded away to almost nothing. Okay? Well, the same thing happened back in Beethoven's time. When he was at his prime, he was writing grand symphonies and other things like this, which were the going thing at the time. Everybody loved them, and here comes Ladarius. Everybody loves him too. Let me mark him present. Bottom part of the alphabet is coming in pretty strong here. Hopefully others will keep coming. Okay. So, Ladarius, I'm telling a dumb story on Beethoven now. We've just been doing composition of functions, decomposing functions, that kind of stuff. So, here's the story on Beethoven. So, after a while, sure enough, taste in music changed. People got tired of the grand symphonies. They wanted something a little lighter, a little more fun, things like this. Well, Beethoven's forte was these grand symphonies. He probably worked at some of the other things, but he just couldn't get as much work. He was also getting older. He was old, past tense, you know. We don't care for that anymore. So actually, as grand and wonderful a musician as he was, he couldn't get commissions anymore. He became poorer and poorer. His health started failing. Guess what? He went deaf. Okay, started going deaf. And that's pretty tragic for a musician. Here's what I've heard that he did. He cut the legs off of his piano, so it sat flat on the floor. He sat on the floor with him. Even when he couldn't hear the music well, he could feel the vibration of the music and basically picture what it was sounding like. That is an incredible mind. So he continued composing music even after he was mostly or totally deaf. And still it was wonderful, beautiful music, but no one was buying it. So in time, Beethoven, you know, as in all men, you know, got older, and he was poorer, and he was living in some poor low dump somewhere. He actually died. Okay, no one had. I don't think he had any family. I think the landlord, the cleaning lady, somebody found him dead in his part. Not enough money, so they just buried him what they called the potter's field. Okay, some place where they put indigent people who couldn't afford a big fancy funeral or things like this. They just hauled them off and buried them in the potter's field. Well, sometime later, there was, as it happens with music, there was a revival of the symphonies. And someone said, hey, the greatest symphony writer of all time, in their mind, was Beethoven. Where is he now? What happened to him? Is he still composing? Well, they went out and checked and found out, no, he had died. Okay, and not only had died, he had been buried in a potter's field. They said, no, this will never, ever do, because he needs to be remembered. His music is some of the greatest that's ever been written. We need to move him to a grand place so people can go and celebrate his life and his music. So they had to go through all the procedures to get him exhumed and moved to a place to put a big mausoleum there and remember, this is where, here lies Beethoven. Well, they went out finally and got everything done. They hired this old guy or two to dig the grave up, and they were hauling the wooden box, the casket, out of the ground, and somebody slipped. And when they did, it sort of fell. The lid popped open, and there sat Beethoven with scores of music in front of him. He was erasing like crazy. What was he doing? Anybody? He was decomposing. Never mind. Okay. I told you it was a dumb story. Okay. We have just decomposed a function. Okay. Never mind. All right. Let's go back to, it works better in the classroom. Let's see if we can get to the PowerPoint again. Okay, here we go. We'll go back to the slideshow, and we're going to the application. All right. Here's example 8. The number N, capital N, is a number of bacteria in a refrigerated food, and it's given by this function. N of t is equal to 20t squared minus 80t plus 500. What does that capital T stand for? N stands for the bacteria. Capital T is the temperature of the food in degrees Celsius. Now it says in a refrigerated food. Okay, now I don't know if you know degrees Celsius, but 0 degrees Celsius is the freezing point. So this is starting at 2 degrees above freezing Celsius, which a Celsius degree is not quite twice what a Fahrenheit degree would be. So 2 degrees above freezing in Celsius would be close to 4 degrees above freezing in Fahrenheit. So that would be between 35 and 36 degrees Fahrenheit. And if you check your refrigerators, if you have something in it, you'll probably notice it's sitting around 35 to 36 degrees. That's where we're starting. And the number of bacteria when the temperature is at 2 degrees, okay, is at a certain level. When it goes up to 14 degrees Celsius, it gets to be quite a bit bigger, okay, believe me. And by the way, 14 degrees is just a little bit below room temperature. Room temperature is considered to be 20 degrees Celsius, and this is about 6 degrees below that, which would be, and room temperature is usually assumed to be about 68 degrees. And if you do 6 degrees below that, that would be something like 12 Fahrenheit below that. So that would be maybe 57, 58, something around in there. Okay, so it's warmed up, not quite to room temperature, but it's warming up. And the number of bacteria is growing, of course. Okay, where T is the temperature of the food in degrees Celsius. When the food is removed from refrigeration, the temperature now is given by capital T for temperature as a function of time, little t is time, in hours, 4T plus 2. In other words, the longer it's out, once you remove it from the fridge, it starts warming up. Okay? And T is in hours. And T here goes from 0 to 3. 0 would be when you pulled it out of the fridge, okay? And 3 would be, well, let's just see. When T is equal to 0, little t is equal to 0, capital T is 2. Look at that. And when little t is 3, 3 times 4 is 12, plus 2 is 14. There that is. So this problem is well posed. It fits. Now, what the question is, find the composition function n composed with t. If I could get my pen to show up. Where in the world are you, pen? Can anyone see where my pen is? Oh, it's way up there. Okay, here we go. Find the composition n of t of t. Okay, well that would be n of t of t, right? And that would be your n function operating on t of t. Well, there it is right here, 4t little t plus 2. Okay, and what does your n function do? It takes what's in the parentheses. Come on. Oh, there, whoa. I don't know what happened there. Okay, here it is. It takes what's in the parentheses, multiplies 20 times that squared minus 80 times that plus 500. So let's do that down here. That would be 20 times what's in the parentheses, 4t plus 2 squared, minus 80 times what's in parentheses, 4t plus 2, and then add 500 to it. Okay. Now, we've got some work to do. We've got to square this binomial. And by the way, I'm going to come up here to the top and do it, I guess. This will be 20. Now, I'm going to do the shorthand because I don't have a lot of room. I'm going to square the first term, 4t. 4t squared is 16t squared plus twice the product of the two. Well, the product of the two are 4t times 2 is 8t. Double that would be plus 16t. Those are little t's now. And square the last term, which is 2 squared is 4, plus 4. Okay, that's a pretty ugly plus sign, isn't it? All right, then we'll do the second term. Minus 80 times 4t, that's minus 320t. Minus 80 times 4t is minus 380t. Minus 80 times 2 is minus 160. And then we add 500 to that. Okay, so that's your n of t of t. Well, we got some work to do on it. Let's distribute this across. 20 times 16 would be 320 t squared plus 320t. I'm distributing the 20 across every term here, plus 80 minus 320t minus 160 plus 500. Pretty big numbers here, huh? The good news is that the plus 320t and the minus 320t adds a 0. Most of the time that will not, but that's okay. So here's what your n of t is. What's left over? 320 little t squared, and then we got to add these together. 80 plus 500 is 580. Subtract 160 from that, and you get plus 420, I believe it is. Okay, so there we found the composition. N of t is that. Now, what does that mean? Interpret its meaning. Its meaning in context. What is N? The number of bacteria. Little t is time. Time out of the fridge. Okay? What this tells you is the longer you go out of the fridge, the more the bacteria grow, right? Started when you pulled it out at time t equals 0 here, and that t was 0, it has 420 bacteria in it. Now, believe me, that may sound bad. Everything has bacteria in it, and it doesn't take much bacteria to get up to 420, okay? Not much at all. A glass of water, you know, is probably going to have 420 bacteria in it. Your body can handle that with no problem. But what happens if we cube that, or take that 3 here, square that, that makes 9. 9 times 320, goodness gracious, what a big number that is. You're in the thousands of bacteria. Okay? So that is what it means. This is the number of bacteria as a function of time. This was number of bacteria as a function of temperature. This was temperature as a function of time. The composite of those two gives you the number of bacteria as a function of time. Okay. Now the B part says find the time when the bacteria count reaches 2,000. Well, the bacteria count is your N. If I can get my cursor, the N. So that's going to be your 2,000 is equal to 320t squared, plus 420. Okay, so what I'm going to do is subtract the 420 from both sides, and that would give me, well, time out. Let's first divide everything by 10. Wipe out these zeros. No reason to carry around bigger numbers when we need to. And then notice that everything here is divisible by 2. So that would reduce that to be 100 is equal to 16t squared plus 21. I like those numbers a little better. Subtract 21 from both sides, and that gives you 16t squared is equal to 79, and divide both sides by 16. Now I'm going to have to use my calculator on that one. I got as far as I could without. You could do it with the calculator. You don't have to do anything I just did. I only have my phone here as a calculator, and I got to find the calculating part. So that will be 79 divided by 16. That gives me something a little bit less than 5, and then the t squared is equal to that. Take a square root of that, so I'm going to have to turn mine sideways to get it into scientific mode and take the square root of that, and I have 2.22 hours. Okay, t is in hours, which where is my pen? There it is. Okay, so t is approximately 2.2 hours. That's how long it takes that 420 bacteria that were in there when you took it out of the fridge to grow to be 2,000 bacteria. Well, what is 2.2 hours? That would be 2 hours and 0.2 of 60. That would be 2 hours and 12 minutes. Okay, now the book doesn't do that. It just leaves it as 2.2 hours. Now, here's an issue, you might say. Well, wait a minute, we just took the positive square root. Would the negative square root too? No, that doesn't make any sense. 2 hours before you put it in the fridge, no, there's no way that it lost. You only take the positive. Because here, when you have t squared is equal to that thing that was, I said, a little bit greater than 5, or almost 5, when you take the square root of that, you have plus or minus. In this problem, time is only positive, so 2.2 hours. And that's how they leave it. And that would be about 2 hours and 12 minutes, approximately. There is a checkpoint there. Any questions on that problem or anything in 1.8? We're finally through with it. Okay? Now, let's see how they do the problem. Sorry about that. Okay? First, n of t is n of t, which means you take the n function and whatever you put inside of there, the 4t plus 2, t, you put that in every place in that n function. Then you have to square that, so that would be 20 times 16t squared plus 16t plus 4, just like we did, minus 80 times that, so they go on and distribute here, plus 500. Then they distribute here, and they get 320t squared plus 320t plus 80 minus 320t minus 160 plus 500. And notice here that the plus and minus 320t's add to 0, so that gives you 320t squared plus, and when you add the 80 to 500 and subtract 160, you get 420. Okay. Now, that composite function represents the number of bacteria. That's what the n is. Now, not as a function of temperature like it was before, but now as a function of time. How are those bacteria growing as a function of time in the amount of time the food has been out of refrigeration? And that's why at Thanksgiving or those other meals, grandma or mom or someone says, hey, we need to get this food in the fridge. Because the longer it sits out there, even though we've eaten all that turkey, we don't want to do a thing. You need to get it in the fridge because those bacteria are going to start growing the longer it's outside. Practical example. Okay. Any questions on example 8? I think that, and the beep, I forgot this. The bacteria count will reach 200 when your n of t is 2,000, when it equals 2,000. And the n of t was 320t squared plus 420. So solve this equation. You'll find that they don't show how you solve it. They just say it gets to 2.2 hours. And then they say, note that when you solve the equation, reject the negative value because it's not in the domain of the composite function, and that is another good reason to reject it. If you go back to the composite function at the very beginning, t was between 0 and 3. So you can't have anything over here in negative 2.2. So that was the other reason you couldn't do it. It doesn't make sense physically, but also it's not in your domain of your function. You're only counting positive hours outside of the fridge. Okay? And that now is the end of the 1.8. Any questions on 1.8? Okay, only 2 vocabulary questions. The first one has 4 blanks, and these should be pretty easy. 2 functions, f and g, can be combined by the arithmetic operations of blank, 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 and blank. What 4 operations did you learn when you were doing arithmetic? Anybody? Addition, subtraction, multiplication, and then division. Okay? Number 2, the blank of the function f with the function g is f circle g of x, which we call f of g of x. What is that called? Look at the very top of the page. What is the title for this 1.8 section? First is the combination of functions. That's what we did question 1 on. The second part is composite of a function f. Composition. Is that what you were going to say?
Yeah.
All right, good deal. Sorry I spoke too soon. Okay. Homework exercises here would be number 3. That should be at calcchat.com. Also in the back of the book, by the way. Any of the odds 5 through 11, they're all at CalcChat. 11's at CalcView. Any of the odds 13 to 23, they're all at CalcChat. 13's at CalcView. 25 or 27, both at CalcChat. 25's at CalcView. Any of the odds 29 to 33, they're all at CalcChat. 33's at CalcView. Any of the odds 35 to 41, they're all at CalcChat. 35's at CalcView. 43's at CalcChat. 45 or 47 are at CalcChat. 45's at CalcView. Any of the odds 49 to 55, they're all at CalcChat. 49's at CalcView. And any of the odds 57 through 63, they should all be at CalcChat. Then there's a true-false 65. It should be at CalcChat. 67 should be at CalcChat. And any of the odds 69 through 73 should be at CalcChat. Any questions on 1.8? Okay. If not, let's... Yes. Okay. It's either way you want to do. Okay. Again, you can do the checkpoints if you want to do that and send them to me. You can do these exercises I'm assigning and send them to me, or you can do them on WebAssign. If you like WebAssign and want to do those, you certainly can do those too. Now, I think you sent me some WebAssign before, and those, when you send me the picture of what you got in WebAssign, I can do that when you just send a link. So far, I haven't been able to get my computer open it up. I must have something that I need to load, and I don't have that on mine. So if you do, send me the picture like you've done a couple of times. I've still given you credit every time, but I'd like to see that picture you take, and you've been doing quite well in WebAssign from what I can tell there. So send me the picture of either the problem itself or your results of what you did in WebAssign. And you don't need to send a whole bunch. You can only send one. But like you've done, you've sent several exercises you did in WebAssign and you showed me the results of that. That's perfectly fine too. Or you can just send me one. Now what I especially would like to see is any you're having trouble with. You can't get that answer, and I remember one of yours you sent, there was one that you didn't get right. You probably figured out what you got wrong, but if you can't figure out what you got wrong, send me those, because that way we can do those in class. Now what were you going to say? No, I mean, do whatever you want to do. The purpose of doing these exercises is to give you practice doing what we've just done in class. So when you sit and hear me do the problem, watch me do the problem, that's sort of passive. You learn a little bit of stuff from that. When you really learn the material is when you do the work. So I would say do as many as it takes for you to say, hey, this is mine, I got it. You know, I only want you to send me a few problems, one or a few if you're having trouble with more than one. Okay, and it's only because they've started this thing of they're treating this like an online class that you have to turn in something every week. Well, you won't really have to, but it's not a bad idea to. So I have to put it out there, and that's what, if you send stuff in, I'll mark it in my grade book and I put it on Blackboard. And in Blackboard, all it shows up is that you turned it in. It's posted. No points, it's just posted. But remember, at the end of the term, if you're right on the borderline, okay, and you've had turned in more posts than not posts, then you may get bumped up. If you haven't turned in more and you're below, say, a B or below an A or something like that, you're going to get whatever you earn. The turning in the homework may bump you up if you're in that borderline situation there. Not quite enough points, but if you turn in enough homework, it goes up rather than rounds down. Okay? Was there another part of your question? That's okay? All right. All right, I hope I answered it. I probably did way more talking than you wanted to hear, but that's probably normal. Now I've got to find 1.9, and I don't see 1.9, so I'm going to have to close out here, go back into PowerPoint, and pull up one. I think first, I'll wait and do that later. Okay, maybe that's why it wouldn't do. Okay, now let's try again. There's 1.9. Okay. And we'll start the slideshow from the current slide. Okay. Can everyone see that now? Still in Chapter 1, Functions and their Graphs. Okay. We're doing 1.9, which is now inverse functions. Okay. I don't know if you recall. Wait a minute. Is it 9:47? Yuck, we've just gone over 2 minutes, okay? That's okay, I won't charge you any extra today, okay? And we've already assigned homework exercises, so we'll start with 1.9 at the very beginning next time, okay? The only reason I'm in sort of a hurry to end is that I've got another class coming up at 10 o'clock. So any questions before we leave? Okay, I'm going to stop the sharing. Any questions? Okay, I see people are already leaving, so take care, folks. We'll see you on Thursday, okay? And maybe see some of you this afternoon if you're in the physical science class. Bye-bye.